in this session we will be talking about various sequences and series. When it comes to talking about the sequence and series, we first of all start talking about some progressions that we have, the standard progressions. We start discussing from the arithmetic progression, then we move to the geometric progression, we have a little discussion around it, and then we do not touch at all the harmonic progression that we learned in school because that's not useful from the GMAT perspective. So here, starting from the arithmetic progression, let me quickly tell you that what does the arithmetic progression mean? Arithmetic progression is simply the series of numbers in which the terms are equally spaced, right? So in the simplest terms, we can explain it this way, in which the terms are equally spaced. What is the meaning of that? Let's quickly understand. For example, if I have a number 1, the next number is 2, so the space here is 1. So the space remains constant and the next term becomes 3, 4, 5, 6. So in a way we can say that the consecutive integers are basically forming an arithmetic progression. Another example of arithmetic progression could be 2, 4, 6, 8, 10, etc. Similarly, another series could be 1, 5, 9, 13, etc. Here the gap everywhere is 4. And the gap that we see, the constant gap between any two consecutive terms, that we call the common difference. So there are several terms, which means if the first term is defined in the series as A and the difference is defined as D, the next term will become A plus D, where D can be positive as well as negative. So I'm just writing plus D does not mean D has to be essentially positive, it can be negative as well. The next term becomes A plus 2D, and then the next term becomes A plus 3D, etc. Here, let me quickly define. A is representing the first term of the sequence. D is representing the common difference. So these are basic terms that we keep using when we talk about arithmetic progression. The common difference between the two terms, which can be represented as either second term minus the first term, or the third term minus the second term, or the fourth term minus the third term, and so on. So T2, T1 are especially to represent that T1 is the first term, T2 is the second term, and so on. So here, when I look at the standard representation of arithmetic progression, I see that if I call A as T1, that means the first term, then T2 becomes A plus D, T3 becomes A plus 2D, T4 becomes A plus 3D. So the first basic principle comes up from this basic observation that in T1 there is no D at all. In T2 there is 1D, in T3 there are 2 Ds, in T4 there are 3 Ds. That means the number of Ds is always 1 less than the number of the term. So in a way, if I am looking at nth term of the sequence, then there will be n minus 1 Ds in it. So the first basic principle gets derived from this basic observation that nth term of any arithmetic progression is defined as A plus n minus 1 multiplied by D. So this is the first basic formula of any arithmetic progression. Now, the second very important formula is about the sum of the terms in an arithmetic progression. To find out the sum, I think we need to focus on one basic observation. So I'll quickly write down an arithmetic progression. Let's take an example such as 1, 3, 5, 7, 9, 11, 13, 15. Right? So here we have 8 terms in this series, right? Let's take rather 9 terms, and after 15 the next will be 17. So here it's an arithmetic progression with the first term as 1, common difference as 3 minus 1 or 5 minus 3, either way you can define it to be 2. It's a series of consecutive odd integers. Now if the challenge is to find out the sum of these terms, then how do we find it out? Just look at this observation. The sum of the first and the last term, that means the smallest and the biggest term of the series, is how much? 1 plus 17, that is 18. Similarly, let's look at the sum of the second and second last term. 3 plus 15 is again 18. Third and third last term is again 18. Fourth and fourth last term is again 18. I categorically took 9 terms so that you can see the scenario in which one term does not form a pair. 9, which is half of a pair, because every pair is giving you a sum of 18, right? And this is half of, because this is half of a pair of 18. So here, if you see that we have 9 terms, then if I were to find out the sum of these terms, you see we have 9 terms and we have got 9.5 pairs because there are 4 complete pairs and 1 half pair. And every pair gives you a sum that is equal to the first term and the last term. This observation itself leads us to the conclusion that sum of n terms in any arithmetic progression can be defined as n by 2, where n is the number of terms, and then every pair will give you the sum that is equal to the sum of first and the last term. So there is another form that we will come across about the sum of n terms of arithmetic progression, but this is the representation that I see is the most beneficial for the students to learn. However, we can turn it into this form. If I write the first term as a, because we have defined that a is the first term, and the last term, that means the nth term, because we are talking about the n terms, and the last term we can see is a plus n minus 1 into d. So this way, the sum of n terms turns out to be n by 2 twice of a plus n minus 1 multiplied by d. This is represented as sum of n terms. The standard representation for it is Sn. So we can also say that Sn, which is sum of n terms in an arithmetic progression, can be represented by n by 2 twice of a plus n minus 1 into d, where n is the number of terms, a is the first term, and d is the common difference. So this is the basic principle of arithmetic progression. Right.